Okay, Unit 4, Lesson 9, Solving Systems Algebraically Using Elimination, Day 2. Solve this system graphically. So let's look to see where these two lines intersect. It's difficult to see, but it's going to be right here at the point 2, 3, 4, 5, 6, 7, 8, 9. Up 1, 2, 3, 4, 5. 9, comma 5. All right, but now let's go over how we would have solved that algebraically. So I'm going to rewrite the two equations. And we want to use elimination. So we learned in the last lesson, for elimination, you look for pairs of the x's or y's that are additive inverses and that will cancel out or eliminate when you add the two equations together. Our x's here are not going to cancel out, and neither are our y's. So we're going to have to do something to one of the equations before we can have something to eliminate. So what we can do is multiply one of the equations by a number to create additive inverses. So I see this negative 4x here, and I want to cancel out my x's. I think that's going to be easier than canceling out my y's, but we actually could do either way. To cancel out my x's, I need this first term in the first equation to be 4x. 4x and negative 4x would cancel. To make this 1x a 4x, I'm going to have to multiply the entire equation by 4. You have to multiply the entire equation because that's the only way to keep it balanced. You can't just multiply one term by 4. You're going to have to do it throughout the whole equation to keep it balanced. And then you're allowed to do that. So let's multiply everything in the first equation by 4. Then I'll get 4x minus 12y equals negative 24. All right, and then I'm just going to keep my other equation the same. We don't need to multiply that one by anything. Now we can add our two equations together and use elimination. 4x plus a negative 4x will cancel. Negative 12y plus 9y is going to give me negative 3y. Negative 24 plus 9 is going to give me negative 15. Divide both sides by negative 3. Y equals positive 5, which is what we found graphically. Okay, so the first thing we did was find y. Now we're going to go ahead and find x. Let's rewrite one of the original equations. I'm just going to pick the first one. I think that's easier. Plug in y. 5 for y. We know that 5 is y. So we're going to plug that in for y. All right, negative 3 times 5 is going to be negative 15. Add 15 to both sides. X equals positive 9. So our solution is x comma y, 9 comma 5, which is what we found graphically as well. Just another strategy to solve systems of linear equations. This was using elimination. Okay, so these are the same steps as the last lesson. We just have one extra step at the beginning. If there are no variable with opposite coefficients, no additive inverses, then you can multiply each of the equations by a constant so that there are opposite coefficients. Then you add them together, you solve, you plug back in, and you get your solution. All right, solve this system algebraically. So let's look for pairs to eliminate. My x's are not going to eliminate, and neither are my y's. So we need to do something to one of the equations to make it so we have something to eliminate. Okay, so let's see. Maybe I want my x's to cancel out. Or maybe I want my y's to cancel out. Let's see which one will be easier this time. Let's see. I'm going to manipulate my x's here. So if this is 3x, I want this one to be a negative 3x. So in order to do that, this is 1x right now. So I'm going to have to multiply everything in that second equation by negative 3. I'm going to rewrite my first equation. We'll do that in pink. And then my second equation is now going to be negative 3x minus 3y equals negative 18. All right. Now we can add our two equations together. Our x's will eliminate. This is 1y, so 1y minus 3y, 1 plus negative 3, is going to be negative 2y 14 plus negative 18 is going to be negative 4. Divide both sides by negative 2. Y equals positive 2. Okay, so I chose to multiply everything in the second equation by negative 3. Someone else may have suggested maybe multiplying by negative 1, and then you'd have a positive 1y and a negative 1y, and that would cancel as well. So that was another way that you could have done it. All right, so now let's take our y equals 2 and plug it back into one of the originals. I think the second one looks easier this time. Okay, so this was step 1. Step 2 now is to find x, because we already found y. So I'm going to rewrite my second equation. I'm going to plug in this y equals 2 for y. So that means x plus 2 equals 6, minus 2 on both sides. X equals 4. Our solution, we can write that down here, is 4, 2. I'm going to show you how to check this one. It's always a good idea for these more difficult problems. You're going to rewrite both originals. The check's pretty quick too, so it's definitely worth it. And then the other original. And we're going to plug in for both x and y. So we said x was 4 and y was 2. Just going to write it like this so I can show you that I'm plugging in. 4 for x, 2 for y, 2 for y. 3 times 4 is 12. 12 plus 2 is 14. So that means that the 0.42 is on that line, and it's on that line as well. All right, number 2. All right, so let's see. Is anything going to eliminate right away when we add these two equations? No. So what can I multiply one of the equations by to get something to cancel out? Well, 5 and 2 are not really multiples of each other, so that's going to be a little bit more difficult. But this negative 1x, if I multiply this equation by 4, then I'll have negative 4x, and that will cancel out nicely. So I'm going to rewrite my first equation. And then for my second equation, 4 times negative 1 is negative 4x. 4 times a negative 2y is going to give me negative 8y. And 4 times 8 is 32. Now when I add these two equations together, my x's will eliminate. Negative 5y plus negative 8y is negative 13y. And let's see, negative 19 plus 32 is positive 13. Divide both sides by negative 13. Y equals negative 1. Now that we know y is equal to negative 1, I'm going to go back to one of my originals and find x. So let's see, I'm just going to use the first one. 4x minus 5y equals negative 19. I'm going to plug in my negative 1 for y. So we have 4x minus 5 times negative 1, because that's what y is, equals negative 19. And let's solve for x. So we've got 4x. Negative 5 times negative 1 is positive 5. Then we will minus 5 on both sides. And let's see, this is going to be negative 24, right? Negative 19 minus 5 is negative 24. Divide both sides by 4. X is negative 6. That means our solution is negative 6, negative 1. And for this one, I'm just going to check it in my calculator instead of writing it all out. Let's see if you can see this without the glare. There we go. Okay. So my x is negative 6. So it's 4 times negative 6 minus 5 times negative 1, because that's our y. And we should get negative 19. And we do. Cool. Let's try the next one. So it was negative x. So that would be a negative 6 minus 2 times y. So 2 times negative 1. And that should equal 8. And it does. Moving on. All right, so for number 3, do we see anything that's going to eliminate right away? Nope. But what can we manipulate here? 3 and 5, I don't really see anything you can multiply by to make those multiples, to make those end up being additive inverses, but the y's are easy to work with. I want this y to be a negative 3y. So I'm going to have to multiply everything in my first equation by negative 3. And then we'll have a negative 3y that will cancel with our positive 3y. So negative 3 times negative 3x is going to give me positive 9x minus 3y equals negative 3. And then I'm just going to rewrite my other equation. Now we're going to add them together, and sure enough, our y's cancel. 9x plus a negative 5x gives you 4x. Negative 3 plus 11. Negative 3 plus 11 gives you 8. Divide both sides by 4. And x is 2. All right, now we found x. We have to go back and find y. Let's pick one of the equations. I'm going to pick the first one. That looks a little bit easier to me because the y is by itself there. Well, the y doesn't have has a coefficient of 1. All right, let's take this x equals 2 and plug that in. And then we'll solve for y. Okay, so I'm plugging in my value of x is 2. Negative 3 times 2 is negative 6. Add 6 on both sides. And we determine that y is 7. So our solution is 2, 7. To check it, I'm going to check it in the calculator again. The first equation is negative 3 times x, so negative 3 times 2 plus y, so plus 7, has to equal 1, and it does. Next equation is negative 5 times x, so negative 5 times 2 plus 3 times y, so 3 times 7, should equal 11, and it does. Awesome. These longer ones, I definitely recommend that you check. Okay, number 4. Let's see, what's going to eliminate? Negative 2x and 4x, 7y and negative 2y. The 7 is kind of intimidating, but this 2 and 4 are easy to work with. I want this first equation, I want this term with the x to be negative 4x, and then negative 4x and 4x will cancel. To make this negative 4, I'm going to have to multiply everything by 2. 2 times negative 2 will give me that negative 4x. 2 times 7y is 14y, and 2 times 8 is 16. Rewrite my other equation below it. Now let's add them together, and our x's will eliminate. Goodbye x's. 14y's plus a negative 2y is going to give you 12y. 16 plus 8 is going to give you 24. Divide both sides by 12. And we determine that y is 2. Now let's take that y is 2 and use it to help us find x. Let's rewrite one of our equations. I'm going to pick the second one. Right, that 7 is intimidating to me. Y equals 2. Let's plug that in. 4x minus 2 times y equals 8. So instead of y, we can put 2. And now we can solve. So let's see, negative 2 times 2 is minus 4. Add 4 to both sides. 4x equals 12. Divide both sides by 4. X is 3. That means our solution is 3, 2, because it goes x, y. And our check. So the first equation was negative 2x times x. So negative 2 times, our x is 3. So negative 2 times 3 plus 7 times the y, which is 2, should equal 8, and it does. 4x, so that would be 4 times 3. So our x is 3. Minus 2y, so minus 2 times our y, which was 2, should give you 8, and it does. Awesome. Okay, we have 3 more. Okay, let's see what's going to eliminate. Oh boy, this one's a little bit tricky because we're going to have to multiply both equations by a different number. So let's see. 5 and 3. If I know that they're both multiples of, or I'm sorry, they're both factors of 15. So I can turn these both into a 15 and a negative 15. Or my y's, well, the y's we can make 12. Maybe we'll do that. I'm going to work with the x's. I'm going to make the x's 15. That was the one that kind of popped into my head first, so maybe you did as well. I want those to be 15 and negative 15. Come on. All right. So if I want this to be positive 15, I'm going to have to multiply everything by 3. And if I want this one to be negative 15, I'm going to have to multiply everything by negative 5. Okay. So 3 times 5x is 15x. Why is it so blurry? Three times 4y is 12y. 3 times negative 14, negative 42. Our second equation, negative 5 times 3x is negative 15x. Negative 5 times 6y is going to give you negative 30y. And negative 5 times 6 is going to give you negative 30. These are very big numbers, but that's okay. Let's add and eliminate. Our x's are going to eliminate. 12y plus negative 30y is negative 18y. And negative 42 plus negative 30 is negative 72. Let's divide both sides by negative 18. And we'll get y equals 4. All right, now let's find x. So we're going to take our y and plug it back into one of the originals. I think the second original is a little bit easier to work with. So time to find x. 3x plus 6y equals 6. 3x plus 6, let's see what we can plug in for y. We know that y is 4. 3x plus 24 equals 6, because 6 times 4 is 24. And then let's solve our two-step equation. 6 minus 24 is negative 18. Divide both sides by 3, and you're going to get negative 6 for x. So that means our solution is negative 6 comma 4. Right? Our solution always goes x and then y. And let's check. 5 times x, so 5 times negative 6, plus 4 times y, so plus 4 times 4, should equal negative 14, and it does. 3 times x, so 3 times negative 6, plus 6y, so 6 times 4, should equal 6, and it does. Awesome. Okay, cool. Number 6, and then the challenge. All right, we're looking for additive inverses that will eliminate. So we could make this negative 40 and this one positive 40, but those are really big numbers. So maybe we'll make these 14, right? 2 times 7 is 14, so that could work out. So to make these 14 and negative 14, this is a negative 2. So if I multiply everything by 7, then that would be negative 14. And if I multiply everything here by 2, that'll give me a positive 14. So again, a lot of you might have thought right away, like multiply this by 4 and get 40, and multiply this by 10 and get negative 40. And that would work also. But those are really big numbers, so I'm going to pick the smaller numbers. 7 times negative 4x is going to give me negative 28x. 7 times negative 2y is going to give me negative 14y. And 7 times 14, I don't know that one. 98. Okay, and then our second equation, 2 times 10x is 20x. 2 times 7y is positive 14y. And 2 times negative 25 is negative 50. Add and eliminate. Negative 28x plus 20x is going to give you negative 8x. Our y's will cancel. 98 minus 50 gives you 48. Divide both sides by -8. And we get -6. All right, now let's find x. We found x, now let's find y. Rewrite one of the originals. They both look pretty tough, so I'm just going to pick the first one. Let's plug in what we got for x and then solve for y. So if x is -6, let's plug that in for x. -4 times -6 is +24. Now we just have a two-step equation. This is a +24, so we're going to minus 24. 24 minus 24 is 0. Both sides. -2y equals -10. 14 minus 24 is -10. Divide both sides by -2, and you're going to get y equals 5. So that means our solution is -6, 5, right? Remember, the x always goes first. And we can check this. All right, so let's look at our original. This one, -4 times x, which is -6. So -4 times -6 minus 2 times y, and we said y was 5, should equal 14, and it does. 10 times x, so 10 times -6, plus 7 times y, so plus 7 times 5, should equal -25, and it does. And if what I'm doing in the calculator is too much, just write down the check. You can write down the check. That's totally fine. I'm just not. Okay. And then our challenge. All right. So same thing. We want to use elimination. So let's try and make some additive inverses here. All right. So 2 and 6 or 5 and 15. Well, I can turn this into a -6x pretty easily. What kind of challenge is this? This doesn't seem so bad. If I just multiply everything by -3, then this will be -6x minus 15y equals -36, right? I just multiplied everything in the first equation by -3. Rewrite my second equation. Add them together, right? And our x's are going to cancel, just like we wanted. But oh boy, our y's are going to cancel too. Yikes. So then we get 0. We have nothing on this side, so we have to write a placeholder. And -36 plus 36 is also 0. So 0 equals 0, a true statement? Yes, that's always true. Always. So whenever you get a number that equals a number, and that's true, 0 does equal 0, then it's infinitely many solutions. Right? It would have been infinitely. It would have been no solutions if you had two numbers that did not equal each other, like 0 equals 2 or something. So the challenge was infinitely many. All right, that was elimination day 2. Thanks for watching.